In this quest, we are going to learn about differentiation. Now, oftentimes you must have heard something like dy all over dx. Now, this means that a change in y leads to a corresponding change in x. Now, how do we differentiate? If, for instance, you are given, let's say, y is equal to asn, where a is the coefficient of x and n is the power of x. How do you differentiate this? We can say that our dy ds, that is, differentiate y with respect to the variable x, will be equal to, use this n to multiply a, and this gives us na, then x n minus 1. So whenever you are given anything like this, you follow this approach. Use the power to multiply the coefficient of x and then subtract 1 from the power. Now, taking cognizance of this example here, you are given y is equal to s squared. How do you solve this now? Now, you would agree with me that the coefficient of x here is 1. So therefore, our dy dx would be equal to 2 times 1x, then subtract 1 from the power, and this becomes dy over dx is equal to 2 times 1 is 2, then x, 2 minus 1 is 1, and 2x minus 1 is 2x. That is the solution to that question. Now let's take another example. How about you have y is equal to s raised to the power of 3. Now, following the same precept, you agree with me that your dy over the x is equal to, what do? We know that the coefficient of x here is an invisible 1. Okay, coefficient of s here is an invisible 1, so we can say that our dy ds, use 3 to multiply the coefficient here and then subtract 1 from the power. So this gives us 1 times 3, or let's take it as 3 times 1, 3 times 1, then x 3 minus 1. 3 times 1 is 3, then x 3 minus 1 is 2. Your dy dx is equals to 3s squared. So the final answer here is dy over dx is equals to 3s squared. That is the solution to this question. Let's take more examples as we proceed with this quest. Now the next example says y is equal to root x. Now the first thing to do is make this root s to be in the form of index. Now whenever you have the square root of anything, let's say a, this is equal to a raised to the power of half. If you have the square root of b, this is equals to b raised to the power of half. If you have the square root of a square, this equals to a square raised to the power of half. Of course, 2 cancel this, and this gives us a. That is why if you have the square root of anything square, is also the same thing as that value. So if we have the square root of a raised to the power of 3, what would this give to us? This would be what? A raised to the power of 3, then bracket raised to the power of half. This will be a raised to the power of 3 over 2. Now, coming back to our quest, you have y is equal to root of x. The root of x can be written as x raised to the power of half. Of course, we know this can be written as y is equals to, there is an imaginary one here, x raised to the power of half. So how do we differentiate this? Our y will be equal to half times 1, so we say 1 times half. Then x, we have half, then you subtract 1 from half. And sorry, this is not y. Hope I've not been writing that for everything before. Okay, dy dx, we are right. This is not y, this dy dx. Okay, so our dy dx, this is y equals to the dy dx is equals to this. So your dy over dx is equal to 1 times half is half. There you have x. Half minus 1 is minus half. Now this can also be written as dy over dx is equal to half times this negative here. Whenever you have a raised to the power of negative 1, this is the same thing as 1 over a. So if I have x raised to the power of negative half, the same thing as 1 over s raised to the power of half. So we come here, this becomes 1 all over x raised to the power of half. That's the meaning of what we have here. Okay, and this will give us dy over dx is equal to 1 times 1 is 1 all over 2 times everything here will give us 2x raised to the power of half. And that is the solution to this question. Let's proceed with other examples. Let's say you are given y is equal to 1 over x. Now 1 over x is still the same thing as s raised to the power of minus 1, because we said that a raised to the power of minus 1 is what? 1 over a. So s raised to the power of minus 1 is 1 over x, and vice versa. So we can say that 1 over x is equals to x raised to the power of minus 1. So this becomes y is equal to s raised to the power of minus 1. Now why are we putting them in the index form? It's so that we'll be able to have a power to multiply the coefficient of x and then a power to separate from, or to subtract from rather. So our dy dx now would be equal to, there's an imaginary one here, so this is 1 times, if this power multiply the coefficient here, which is an imaginary one, it becomes minus 1, and then x, you have minus 1, subtract 1 from the power, becomes minus 1 again. So your dy over dx is equal to 1 times minus 1 is minus 1. Then we have x, minus 1 times minus 1 is minus 2. And then your dy over dx is equal to minus 1, or let's say minus 1 x raised to the power of minus 2. Now this can also be written as dy over dx is equal to minus 1 times, now x raised to the power of minus 2 is still the same thing as 1 over s squared, because a raised to the power of minus n is the same thing as 1 over a n. So if I have s raised to the power of minus 3, this gives us 1 over s raised to the power of 3. So coming here, s raised to the power of minus 2 can be written as 1 all over s raised to the power of 2. Minus 1 times 1. This will give us dy over dx is equal to minus 1 all over s squared. And this is the final answer to this question. Let's take the next question. The next says, if y is equal to 1 all over root x, find dy dx. Now we said that root x is equal to what? Root x, same thing as s raised to the power of half. Since root s is equal to s raised to the power of half, so we have y is equal to 1 all over s raised to the power of half. Now 1 over a raised to the power of n is still the same thing as a raised to the power of minus n. We've established that fact before. So y is equal to s raised to the power of half. This becomes 1 times, if you want to make this linear, s raised to the power of half, if it comes up, it becomes x raised to the power of minus half. Because x raised to the power of minus half, this negative here means 1 over then s raised to the power of half, and that is what we have here. So our y would be equal to, we have an invisible one here, this is 1, x raised to the power of what? Minus half. So what would be our dy dx? Dy dx would be equal to, this is x raised to the power of, okay, sorry about this, you use this power, of course you know that this is power to this minus 1 over 2, you use this power to multiply 1, so this becomes 1 times minus 1 over 2 x, then minus half, you subtract 1 from the power, use the power to multiply the coefficient of x, and then subtract 1 from the power, and this leads us to dy over the x is equal to 1 times minus half is minus half, then we have x. Now if we simplify this part of this equation, what are we going to have? This will give us minus half minus 1 over 1. We must put it in fractional form. What is the LCM of 2 and 1? Is 2. We have 2. 2 divided by 2 is 1 times minus 1 is minus 1 minus 2 divided by 1 is 1 times minus 1 is minus 2. So this is equal to minus 1 minus 2 is minus 3 over 2. So everything we have on top here is minus 3 over 2. So this gives us minus 3 over 2. Now you may want to leave this answer like this, but we can still progress. Our dy over dx will of course be equal to this minus half times, whenever you see a negative here, what you do is turn it to a fractional form by saying this is 1 all over everything aside from the negative. So this becomes x raised to the power of 3 over 2. Now minus 1 times minus 1 times 1 will give us dy over dx is equals to minus 1 times 1 is minus 1 all over 2 times this will give us 2x 3 over 2, and this is the answer to this question. Okay, this is the answer to this question. Let's take another example. Now how about you are given 4 root x? Now these are two things. There is a case where you have a root n. What this means is a times root n is what? N raised to the power of half, which is a n raised to the power of half. That's the meaning of this. However, if you have a situation where you have the a inside the root, then you have n. This means n 1 over a. That is the meaning of this. So if I have, let's say 2, then root with the root inside, let's say x, this will be what? X 1 over 2. What is in this outside root here? So in this case that we have 4 roots with the root, the 4 inside the root x, this will be written as x raised to the power of 1 over 4. So we can say that our y now is equals to s raised to the power of 1 over 4. To find dy dx, that will be equal to, now what do you think your dy dx will be? I've guessed that you tried to provide solution to the question and you've gotten your answer. Can you try and let's see what you arrive at. Possibly you might have arrived at a particular answer. Now what we do is, as a rule of thumb, take this half, 1 over 4, use it to multiply the coefficient here. The coefficient here is 1. Now don't always believe that the coefficient here will always be 1. There are cases where the coefficients are not 1, okay? So this will be equals to 1 over 4, then x, then subtract 1 from the power. This becomes 1 over 4 minus 1. And our dy dx is equal to 1 over 4 x. 1 over 4 minus 1. We can come here and say 1 over 4 minus 1 is the same thing as 1 over 4 minus 1 over 1. Because 1 over 1 will still give us 1. The LCM of 4 and 1 is 4. Divided by 4 divided by 4 is 1 times this is 1 minus 4 divided by 1 is 4 times minus 1 is minus 4. 1 minus 4 is minus 3 all over 4. So this is equals to minus 3 all over 4. Your dy over dx is equals to 1 over 4 times 1 all over x, then 3 over 4. Why is it s raised to the power of 3 over 4? We say whenever you have a negative power here, you put 1 all over everything aside from the negative. So our dy dx would be equal to 1 times 1 is 1 all over 4 times this is 4x raised to the power of 3 over 4. Now this is power 3 over 4. Please take notes. Now this is the solution to this question. Can we take another question briefly? Oh yeah. Now we have another question that says y is equal to the root of s raised to the power of 3. Now from all we have learned, if we express this in the index form, this becomes y is equals to s raised to the power of 3 times 1 all over 2, because root means 1 all over 2. And this will be y is equal to s, 3 times 1 is 3, then all over 2. Now dy dx would be equal to what? You use this 3 to multiply the coefficient here, of course, which is invisible 1. So we are celebrating 1 day today. 1 1 1 1 1 for all the questions we'll be taking. Maybe it's just a mere coincidence. So this is 3 over 2 times 1 is still 3 over 2. Then we have x. Subtract 1 from the power, it becomes 3 over 2 minus 1. Now 3 over 2 minus 1, we have it 3 over 2 minus 1 over 1. What is the LCM here is 2, so we have 2 all over 2 divided by 2 is 1 times 3 is 3 minus 2 divided by 1 is 2 times 1 is 2. 3 minus 2 is 1 all over 2, because 3 minus 2 is 1, then all over 2. And then your dy dx would be equal to 3 over 2 x. We said 3 over 2 minus 1 is the same thing as what? Half. So this is the solution to this question. Now you may want to write it as dy all over dx is equal to 3 over 2 s raised to the power of half means what? The square root of x. So this may be written as 3 over 2. dy dx is equals to 3 root x all over 2. And that is the solution to that question. Let's take the next. How about you have something like this? Y is equal to s raised to the power of root 2. Now, I would suggest that the best way to go about this question is, because root 2 means 2 raised to the power of half, and that one has its own value. Leave root 2 as it is, and then simplify, or find the derivative. So your dy dx would be equal to Root 2 is the power here. Use root 2 to multiply the coefficient here, which is 1 in this case. So root 2 times 1 x, then subtract 1 from root 2, so this becomes root 2 minus 1. And the final answer to this question is dy dx is equal to root 2 times 1 is root 2, then you have x, then root 2 minus 1. Now, if you know the value of root 2, which is 1.414, something like that, you can substitute in and then find your answer, but I would suggest you end here. So this is the answer to this question. Let's proceed. Now you are given this question. How do you solve it? The ones I've been doing since are the ones with just one variable, like there is no addition nor subtraction. It's independent, like it's independent, just one standing on its own. So we have y is equals to s squared plus 3x. What do? We differentiate each of these one as if they are standing alone and then sum them as they are. So this will give us dy over dx is equal to, if you differentiate s squared, there's a visible one here, so this becomes 2 times that one x, then subtract 1 from the power 2 minus 1, plus, of course, you know that 3x standing on its own means 3x raised to the power of 1. The power there is 1, because power of anything standing on its own is what? 1. So use the 1 to multiply 3. This will give us 3 times 1, then we have x, subtract 1 from 1, this will give us 1 minus 1. And then what will be our answer? Dy over dx would be equal to 2 times 1 is 2, x, 2 minus 1 is 1, of course, plus 3 times 1 is 3, then x, 1 minus 1 is what? Is 0, okay? So our dy all over dx would be equal to 2, then you have x plus 3, according to the law of indices. Anything raised to the power of 0 is what? 1. So this is times 1, because s raised to the power of 0 is 1, a raised to the power of 0 is 1, 1 million, okay? Raised to the power of 0 is 1. Anything raised to the power of 0 at all is 1. So this gives us 2x plus 3, because 3 times 1 is 1. So our dy over dx is equals to 2x plus 3. Let's proceed. How about you have this? We are given this. Find dy dx. Now we follow the same approach again. We are given y is equals to s raised to the power of 3 plus 2s squared plus 1 all over root x. Now let's make it in the Lilian form first before we solve. We know that y will be equals to what? S raised to the power of 3 plus 2s squared plus 1 all over root s is equal to what? Let's take it out here and simplify. This will be equal to 1 all over root s is the same thing as 1 all over s raised to the power of half. And then we said when you have 1 all over anything, it can be written as s raised to the power of what? Minus half, because this will give us 1 all over s raised to the power of half. So this can be written as s raised to the power of what? Minus half. Now find dy dx. What do we do? 3 times the invisible one here makes it to be what? 3. Then x, 3 minus 1, subtract 1 from the power, plus, now this is 2. The coefficient here is what? 2. So we say 2 times 2, and this gives us 2 times 2, x, then you subtract 1 from the power, 2 minus 1, plus, brackets. Now there's an invisible one here, so this gives us 1 times, if minus half comes here, becomes minus half, then we'll have x, we have the power minus half, then minus 1 from it, and this will give us dy over dx is equals to 3x. 3 minus 1 is 2, plus this becomes 4x. 2 minus 1 is 1, then plus brackets 1 times minus half is minus half x, minus half minus 1 is what? Minus half minus 1. This over 1, because anything over 1 is still the same thing as 1. So this gives us 2. 2 divided by 2 is 1, times minus 1 is minus 1, minus 2 divided by 1 is 2, times minus 1 is minus 2, and this gives us minus 1 minus 2 is minus 3 over 2, and this everything here gives us minus 3 over 2, and our dy dx will be taken as 3s squared plus 4s plus times minus is minus, then we have half s raised to the power of minus 3 over 2. Now we can decide to end here, or maybe take just one more step to get our final answer. We can say that our dy dx, writing other things as they are, this gives us 3s squared plus 4x minus half. Now this s raised to the power of minus 3 over 2 is the same thing as 1 all over s raised to the power of 3 over 2, because so whenever you have negative here, this negative, whenever you have negative 3 over 2, it means 1 all over that. If you have negative power, become 1 all over whatsoever you have to the power positive. So our dy dx would be 3x squared plus 4s, then minus 1 times 1 is 1 all over 2 times x is 2x 3 over 2, and that is the final answer to this question. Okay, that's the final answer to this question. You may want to erase this so that the answer will be visible. This is the final answer to this question. Let's continue to other questions. Now, how about you are given something like this? We are going to use a rule that is called the function of function. Now, the function of function says that if you are given anything, let's say y is equals to this, you use the formula. Your dy dx is equal to dy du times du all over the x. Now we are going to use two methods, the normal method and then the method, the shortcut rather. Now whenever you are given something like this, you have y is equal to 2x minus 1 raised to the power of 3. What you do is make everything inside the brackets to be equal to a particular number. In this case, you use u. So you say your y, let's say, let u be equal to everything in the bracket. So this gives us u is 2x minus 1. So your du over dx will be equals to, differentiate 2s, what will it give to you? 2. Then this minus 1 will give us 0. Whenever you differentiate a constant, it gives you a 0. So du all over dx will be 2 minus 0 is what? 2. So everything with u, differentiating u with respect to s is written as du over ds. If you have, let's say, u is equal to 2 theta minus 1, then this one will be du d theta, because theta is the dependent variable or the independent variable here. Okay, so that is how to solve for du ds in this case. Now recall that you said let u be equals to 2s minus 1. So your y will also become, you have normally y is 2s minus 3, okay, 2s minus 1 raised to the power of 3. But you said let your u be equals to 2s minus 1. So your y will be equal to u raised to the power of what? 3, because your u now is now 2x minus 1. So wherever you see 2x minus 1, you can put the value of u. And then your dy over dx would be equal to, differentiating this, you use 3 to multiply here. This is an invisible one here. So 3 times 1, then u, then subtract 1 from the power, which is 3 minus 1. Now you don't write this as dy dx, you write this as dy du, because you are differentiating y with respect to u. That means an increase in y, how will it affect u? That's the meaning of what you are doing. So your dy du is equal to 3 times 1 is 3, then u, 3 minus 1 is 2. Hence, substituting, the formula says dy dx is equal to dy du times du dx. Now, why is it like that? If you use du to cancel du, what are you left with? Dy ds. So dy ds equals to dy ds. So the equation is consistent dimensionally. Now, your dy dx here will be equal to, what is the value for your dy du? Dy du is 3u squared times, what is the value for your du ds? Du ds is what? 2. So your final answer here becomes dy dx is equal to 2 times 3 is 6. There you have u squared. And finally, dy dx will be 6. What was your value for your u? We said let u be equal to what? 2x minus 1. So the value for u here becomes 2x minus 1 square. And this is the final answer to this question. Now, however, there is a more simpler way of dealing with problems like this. Let's say shortcut. Instead of following through this procedure, you may say that this, your y, is 2x minus 1 raised to the power of 3. Now, that would give us a particular answer. What would be that answer using the shortcut method? The answer would be, first of all, differentiate what you have in the brackets. So if you differentiate what you have in the bracket, your dy dx now will be equal to, differentiate what you have in the bracket. If you differentiate 2x, it will give you 2. Differentiate 1, it will give us what? 0. So everything in the bracket differentiated gave us what? 2. Are you getting it now? Then use this power to multiply it, which is times what? 3. Then bracket. Write everything in the bracket again, which is 2x minus 1. Subtract 1 from the power. 3 minus 1 is what? 2. So your final answer is 2 times 3 is what? 6. And then you have 2x minus 1 squared. That is the approach to solving this without undergoing through these procedures. First of all, differentiate what is in the bracket. 2, multiply it by the power here. Then write what is in the bracket again and then subtract 1 from the power. It's as easy as that. Let's take another example and then solve with the shortcut method quickly, since the exams will be objective. Now you have this. What do you do? First of all, we say let y be equal to s squared minus 1 raised to the power of 6. I told you that the first thing you do is differentiate what is in the brackets. If you differentiate what is in the bracket, what is it going to give you? If you differentiate s squared, it's going to give us 2x. Differentiate minus 1 is 0, so 2s minus 0 is still the same thing, times multiplied by what you have on the power, which is 6. Write everything in the bracket again, which is s squared minus 1, and then subtract 1 from the power, which is raised to the power of 5. So 2x times 6 is 12x, and this gives us s squared minus 1 raised to the power of 5. This is the solution to this question. Okay, now let's continue with the next question. The next says, given that cos raised to the power of 5x, or y is equals to cos raised to the power of 5x, find dy dx. Now, how do you solve this? How about you have something like this? You say let your y be equals to cos raised to the power of 5x. Now this can also be written as y is equals to cos x raised to the power of 5. Now if you have this, you can say let u be equal to everything in the brackets. Now as a rule of thumb, we can actually use the shortcut method to solve this. So let's say y is equals to this cos x raised to the power of 5. According to the shortcut, differentiate what is in the bracket, right? And then multiply by the power, then subtract 1 from the power. Write what is in the bracket again, then subtract 1 from the power rather. So your dy over dx will be equals to shortcut. If you differentiate cos x, I gave you the value. Say when you differentiate cos s, what will it give to you? Minus sine s. So you have minus sine x, then multiplied by the power you have here. The power you have here is what? 5. Then write what is in the bracket again, which is what? Cos x. Then the last step is subtract 1 from the power, which is 5 minus 1. So our dy dx will be equals to 5 times this, it will give us minus 5 sine x cos s raised to the power of 4, because 5 minus 1 is 4. And then your dy dx is equals to minus 5 sine x, then cos. If you use this to multiply what you have here, it gives us cos 4s. That is the answer to that question. Now let's take it again. I said if you have y is equals to cos 5x, it can be written as y is equals to cos s raised to the power of 5. According to the shortcut formula, your dy dx would be equals to differentiate what is in the bracket first, multiplied by the power, write what is in the bracket again, then subtract 1 from the power. And this gives us minus, if you differentiate what is in the bracket, cos s is what? Minus sine s. So you have minus sine s. Then you have times, the power here is what? 5. Then bracket cos x. Then 5 minus 1. Sorry for that, could not enter that put. So this gives us dy dx is equals to minus 5 times everything you have here is minus 5 sine x, then cos s raised to the power of 4, and dy over dx is equals to minus 5 sine x. Use this 4 to open through, it gives you cos 4s. That is the solution to this question. Okay, solution to this question. Let's take another question. Now this one says if you have y is equal to 1 plus s square. Now can you try this? One of the ways to do this is use the shortcut method. Since the exam is subjective, we will always be taking the shortcut method. Our dy over dx would be equal to, the shortcut says differentiate everything in the bracket first. If you differentiate 1, it will give us 0, plus differentiate s squared, this will give us what? 2x. Then multiply by what is in the power here, which is times 2. Write what is in the bracket again, 1 plus s squared. Subtract 1 from the power, 2 minus 1 is 1. And then dy dx will be equals to 2s times 2 is 4x, brackets 1 plus s squared, because anything raised to the power of 1 is still the same thing. So this is the solution to this question, 4s bracket 1 plus s squared. Do we continue? Should we continue, or we can end here? We can continue with this. This will give us dy dx is equals to 4s times 1 is what? 4x. Then 4s plus this is 4s raised to the power of 3, because s times s squared will give us s raised to the power of 3. And this can be written as dy dx is equals to 4s raised to the power of 3 plus 4x. That is the solution to that question. Now, how about you have this question? How do you solve it? Now, it follows the same approach. But in this case, I would actually advise you to follow the long method. Okay, follow the long method, or better follow the long method. Follow the long method. Now we say let y be equals to sine this s square plus 3s minus 1 raised, there's no power here. So what you actually do is this becomes, say let u be equals to s square plus 3x minus 1. So your y now will be equals to, since u is equals to here, it means that wherever we see this, we can put the value of what? U. So our y will be what? Sine u, because your u is what? S squared plus 3s minus 1. So what will be your dy du? It means differentiate y with respect to u. Now if you differentiate sine, it will give us what? Cos. So differentiate sine u, this will give us cos u. Now in the same way, we said our u is s squared plus 3x minus 1. If you differentiate u with respect to s, that is du dx, this will give us, if we differentiate s squared, it will give us 2x plus differentiate 3x, this will give us 3, differentiate minus 1, it will give us 0. So s squared plus 3s minus 1 gave us 2s plus 3. Now the formula says dy over dx is equals to dy over du times du over dx. Now it's expected that you know this formula in your head. So what will be our dy over dx at the end of the day? This gives us dy du, which is cos u, times du ds is 2x plus 3. So we can write this as dy dx is equals to 2x plus 3, then cos u, because 2s plus 3 can be written times this is the same as 2s plus 3 cos u, and then your dy over dx will be equals to 2x plus 3 cos, what is the value for your u? Your u is s squared plus 3x minus 1. So that is the solution to that question. Now if you want to try the shortcut to solving this, you may want to encounter some issue along the way, but we can also do it. Our dy over dx will be equals to, first of all, we said we usually differentiate what is in the bracket. Are we getting it? If we differentiate what is in the bracket, this will give us 2s plus 3. Then differentiate this sign. If you differentiate sign, it will give us what? Cos. Then write what is in the bracket again, and this will give us s squared plus 3x minus 1. Now whenever you differentiate what is in the bracket, what are you supposed to do? Multiply it by the coefficient here, right, which is 1. Okay, but in this case the coefficient here is 1, so 1 times anything is still the same. That's why I didn't bother to multiply here. So this gives us 2s plus 3 cos, then write everything in the bracket again, and that is the solution here. So you can either use the long cut or the short cut. Let's continue with our quest. Now you are given this, I'm telling you to try this now. What will be your answer? You have 10 seconds to try. I believe that you've gotten your answer. Now let's solve. You are given y is equal to 3x plus 4 raised to the power of 5. Shortcut, dy dx is equal to, differentiate what is in the bracket, what is going to give to us? This will give us 3, because 3s differentiated is 3, plus differentiate 4, it will give us what? 0. Now multiplied by the power, which is what? 5. Right everything out again. This gives us 3x plus 4. Then subtract 1 from the power, which is 5 minus 1. Finally, your answer will be 15 bracket 3x plus 4 raised to the power of 4. And this is the final answer to this question. Let's try another one. Now you have this and you have 10 seconds to try. Your time starts now. Now your time has expired. Let's try it together. Your y is equal to 1 minus 2x squared minus 4. What is the answer? Your dy dx would be equal to, differentiate what is in the bracket. This gives us, when differentiate 0, when differentiate 1 it will give you 0. Differentiate minus 2x squared it will give us minus 2 times 2 is 4, then x. 2 minus 1 is 1, so this will give us minus 4x. Then times, multiply by what is on the power, which is what? Minus 4. Write everything in the bracket again, which is 1 minus 2x squared. Then subtract 1 from the power, which is minus 4 minus 1. And then your dy dx is equals to minus 4 times minus 4. This will give us minus 16, or this will give us positive. This negative 4s times negative 4s to give us positive 16x. Brackets 1 negative or 1 minus 2s squared. Brackets negative 4 minus 1 to give us negative 5. So your final answer is dy dx is equals to 16x brackets 1 minus 2s squared to the power of negative 5. Now this can also be written as dy dx is equals to, you have 16x. Now I said that whenever you have negative here, it means 1 all over something, right? So this will be 16x times 1 all over. Write everything here again apart from the negative. So this gives us 1 minus 2s squared raised to the power of positive 5. And this will be 16s times 1 is 16x divided by 1 minus 2x squared to the power of 5. That is the solution to this question. Let's proceed with our quest. Now, how about you are given something like this? How do you solve it? Let's use the shortcut. Y is equal to 3 cos 5x squared plus 2. And the first thing you need to know, you know the derivative here of the trigonometric function. If you differentiate sine s, it will give you cos s. Differentiate cos x, it will give you minus sine x. And differentiate tan s, it will give you sec square s. Now what you do first is differentiate what is in the brackets. Okay, so this gives us 3, which is the constant here. You don't need to differentiate it, you leave it the way it is, times differentiate what is in the bracket. 5s squared will give us, differentiate 5s squared, 2 times 5 is what? 10. Then you have what? S. 5s squared will give us 10s differentiated plus 2 is 0. Then you are going to write differentiate cos x. What will it give to you? To give you minus sine s. So this gives us times minus sine, then write everything again, which is 5s squared plus 2. So this gives us 3 times 10 is what? Minus this positive 30x minus sine, this times minus sine 5s squared plus 2. And finally 30s times minus sine, this will give us minus 30s sine 5s squared plus 2. So that is how to solve this question. Let me take it again. You have y is equals to 3 cos 5s squared plus 2. What do? We say dy over ds is, this value here is a constant, so you take it down times differentiate cos. What will it give to you? To give you minus sign. Anyone can come first. Differentiate what you have here. What will it give to you? To give you, or better, let's take it the precedence, the normal way it follows. Write down the 3 as a constant. Differentiate what you have in the bracket here. This will give us 10x. Differentiate the cos now to give us minus sign. Then write everything in the bracket again, which is 5s squared plus 2. And this gives us 3 times 10 times minus sign to give us minus 30x, then sine 5s squared plus 2. And that is the solution to that question. Let's take the next question. Next question says your y is equals to 3 tan 4 3x. Now how do you solve this question? The best way to solve it, use the normal method, which says dy dx is dy over du times du all over dx. Now we say let y be equals to tan raised to the power of 4s, right? If y is equals to that, we can say that this can be written as y is equals to 3 tan 3x raised to the power of what? 4. Because this 4 here means what? A power outside that multiplied everything here. Okay? And this will give us, if you differentiate this, what is it going to give to us? To give us, or let's say, let u be equals to tan 3x. Let u be equals to tan 3s. So our y now will be equals to what? 3. In place of u, we are going to put what? In place of tan 3s, we are going to put u rather, raised to the power of 4. So your dy du, you are differentiating y with respect to u. You use 4 to multiply 3, and this gives us 3 times 4. Then you write u and then minus 1 from the power. So your dy over du is 3 times 4 is 12 u. 4 minus 1 is 3. Now let's come back to u. We said u is what? Tan x, tan 3s. We want to look for du dx. Now if you want to differentiate tan 3s, the first thing you do is differentiate 3x. If you differentiate 3s, what will it give to you? It will give you 3. Then differentiate tan x. What will it give to you? Tan x will give you sec square. Then write the 3x again, which is 3s. So u is equals to tan 3s is du ds is equals to what? 3 sec square 3 what x. What I did was, first of all, I differentiated 3x. That gave us 3. Now differentiate tan x without the 3. That will give us sec square. Then add what? This 3s here, which is now sec square what? 3s. So du ds is 3 sec square 3x. And finally, your dy over dx will be equals to dy du times du all over dx. Now dy dx will be equals to what? What is your dy du? Dy du is 12u raised to the power of 3 times your du dx is what? Du ds is 3 sec square 3s. So your final answer to this question is dy over dx is equal to 12. What is your u? We said u is tan 3x, then raised to the power of 3 times 3 sec square 3x. Sorry to write it there. Let me write it where it will be visible. So this will be dy dx is equals to, you have 12, your u is tan 3x raised to the power of what? 3 times 3 sec square 3x. Now 3 times 12 is 36. There we have tan. This 3 open through this tan, it gives us tan 3x times, there we have sec square 3x. And finally your dy ds will be 36 tan raised to the power of 3x sec square 3s. And that is the final answer to that question. That's the final answer to that question. Okay, let's proceed with the next question. Now, how about you are given something like this? This y is equal to 2 all over 2t raised to the power of 3 minus 5 raised to the power of 4. And then we can say y is equals to 2. Now, if this 4 must come up, whenever you have 1 all over a raised to the power of n, if it must come up to become a linear form, it becomes a raised to the power of minus what? N. So if this 4 and this group must come up, what do? Introduce negative here, okay? So this gives us 2t raised to the power of 3 minus 5 negative what? 4. Now, this becomes dy dx. To find the y dx, what do we do? First of all, write our constant 2, differentiate what is in the bracket, multiply it by the power, write what is in the bracket, subtract 1 from the power. So this gives us, when you differentiate what is in the bracket first, we give us 3 times 2 to give us 6, then what? T, which is 6t. Differentiate minus 5, 0. So we have times, what is the power here? Minus 4. Write what is in the bracket again, which is 2t raised to the power of 3 minus 5. Subtract 1 from the power, which is minus 4 minus 1. Finally, your answer, dy dx, would be equals to 12 times 6 times minus 4. 12 times 6 is 12. 12 times minus 4 is minus 48t bracket 2t raised to the power of 3 minus 5. Minus 4 minus 1 is minus 5. And that is the solution to this question. So we can say that our dy dx is equal to minus 48t times, we say whenever you have minus negative here, if you want to make it to be the fractional form, it calls 1 all over, then this is 2t minus 5 raised to the power of 5. And the final answer to this question is dy over dx is equals to minus 48t divided by 2t raised to the power of 3 minus 5 raised to the power of 5. And that is the solution to that question. Let's proceed with another question. How about you have something like this? Now this is function of the function of the function. How do you solve it? First of all, we say y is equals to sine bracket sine bracket sine x. Now we'll break this down. We can say let u be equals to what? Everything in the bracket. Everything in the bracket is what? Sine, then bracket of what? Sine x. Therefore your y will be what? Sine. In place of sine bracket sine s, you put what? U. Now we know the formula for the function of function, which says dy dx is equal to dy du times du all over dx. So what will be your dy du now? We must look for dy du and du ds. Dy du will be what? Dy du will be, when differentiate sine according to what you have here, it will give you us what? Cos. So differentiate sine u, it will give you cos u. So our dy du is equals to cos u. But how do we get du ds? You have u is equals to sine bracket sine x. Now to get du over ds, first of all, differentiate what you have in this bracket. If we differentiate sine s, it will give us what? It will give us cos s. Now differentiate this sign and then write what you have here again. So this gives us sine bracket sine x again, because we differentiated this, it gave us cos x. Okay, we are going to differentiate this. Sorry, if we differentiate sine, it will give us cos, and then write what is in the bracket again, which is sine s. It's more like you have sine 3s. What did we do? We differentiated 3 to give us 3s to give us 3. Then you write differentiate sine to give us what? Cos. Then write 3x again. Okay, that was what we did. First of all, differentiate 3s to give us 3. Differentiate the sine to give us cos. Then you write 3s again. Same thing applicable here. If you have du ds, what do you have here? Let's assume that this one is now our 3x. Okay, u is our 3s. So what are we going to have? Oh, sorry, u is equals to sine s. This will now be 3. This will now be sine s. Sorry. If you differentiate sine s, it will give us cos s. So this will now be cos x. Then cos. What is our 3s? We said our 3s is what? Sine s. So here will become sine x. And that was how they got this. Let me take it again. It looks a little bit confusing, but then we should be able to think it out. So the first thing you do, differentiate the what is in the bracket, which is sine s. Differentiating sine s, it gives us cos s. Then you differentiate this sine, which is outside the bracket, to give us cos. Then write the sine x again. Let me take it again. Differentiate what is in the bracket to give us cos s. Differentiate this sign outside to give us cos. Then write what is in the bracket again. I said it's more like a case of you have sine 3x. What do you do? Differentiate what is here. The 3s is like what is the bracket. So this will give us 3. Differentiate the sign to give us cos. Write what is on the bracket again. This. So same thing applicable here. Differentiate the sign x in the bracket to give us cos s. Differentiate this sign to give us cos, and then write sine x again. So that is our du ds. Now what will be our dy all over dx? Dy over ds will be dy du times du over dx. So finally our dy dx will be equals to, what is your dy du? Dy du is cos u, okay, times, what is your du ds? Du ds is cos x, cos, then sine x. Now this is a very long one. Your dy dx, let me take it where we can easily simplify it, or let me create space for it here. If we demarcate this part like this, so that will not interfere. Okay, what will be our dy dx now? Dy dx will be equals to cos. What was your u initially? U is what? Sine bracket sine x. So this will be times cos x times cos bracket sine x. It's a very long and confusing one, but then we should be able to provide solution to it. Now what do we do at this point? Do you think we can do anything tangible here? So I believe this should be the final answer to this question. Dy over dx is equals to cos bracket sine s times cos x cos bracket sine x. And that is the final answer to this particular question. That's the answer. Now let's continue with the next question. The next says you have 3 sine 2s plus cos 7s raised to the power of 10. Now the difficulty is now becoming more. So this becomes y is equals to 3 sine 2x plus cos 7x raised to the power of 10. Now the first thing you do here is differentiate everything in the bracket first, write everything in the bracket again, then subtract 1 from the power. Differentiating everything in the bracket, if you differentiate 3 sine square s, what is it going to give to you? Now this can be written as something like this: 3 sine square s. Okay, this is not square s, this is sine 2x. Now 3 sine 2s will give us 3 times differentiate 2s, it will give you 2, differentiate sine it will give you what? Cos. So we'll have cos 2s plus differentiate cos 7s, this will give us differentiate 7s, it will give you 7, differentiate cos s, it will give you times minus sine, then you write the 7x again, okay, raised to the power of 10. What we have here is, let me show you somewhere here, 3 sine 2x is still the same thing as write 3, differentiate 2x, it will give us what? 2. Differentiate sine to give us what? Cos, then write 2s again, which is 3 times 2 is what? 6, then cos 2x. That's what we have here. So y is equals to 3 times 2 is what? 6 cos 2x. Okay, plus bracket. Now cos 7s. Cos 7s is differentiate 7s. What will it give to you? 7. Differentiate cos, it will give you a minus sine. Then write the 7s again, which is minus 7 sine 7x. That's what we have here. 7 times minus sine is gives us what? Minus 7 sine 7x. Now everything multiplied by the power here, which is what? 10 brackets everything again, which is 3 sine 2x plus cos 7x, then subtract 1 from the power, which is 10 minus 1. Let me write it here. So y will be equals to 6 cos 2s is 6 cos 2s, plus times minus is minus 7 sine 7s, then this times 10 will give us everything bracket what? Times 10 brackets, write everything again, which is 3 sine 2x plus cos 7s. 10 minus 1 is 9. So 10 times everything here will give us y is equals to 10 bracket 6 cos 2x, okay, minus 7 sine 7x brackets, then bracket 3 sine 2x, this 2x plus this will give us cos 7s raised to the power of 9, everything in this big bracket. And this is the solution to this question. First of all, differentiate what is in the bracket, which gave us this, multiplied by the power 10, write what is in the bracket again, then subtract 1 from the power, which we simplified to give us this. Okay, now let's continue with this quest. You have this given to you: y is equal to the roots of 3s squared plus 4x minus 1. Now what will be our y? We can say y can also be written as well: 3s squared plus 4x minus 1 raised to the power of what? Half. And your y is equal to let me rewrite it again for writing's sake, okay, minus 1 raised to the power of half. Now what do you do at this point? You use this, differentiate what is in the bracket according to chain rule. Differentiate what is in the bracket. So this will give us 6s plus 4. Now multiply it by half. The power here is half, so you multiply it by half. Bracket, write everything in the bracket again, which is 3s squared plus 4x minus 1, and then subtract 1 from the power, which is half minus 1. This will give us dy dx is equals to, finally this will give us 6x plus 4 times 1 over 2 times bracket 3s squared plus 4x minus 1. Half minus 1 is minus half. Okay, half minus 1 is minus half. And if you take this half out, this gives us dy over dx is half bracket, then this gives us 6s plus 4 small bracket, then bracket 3x squared plus 4x minus 1, everything raised to the power of minus half. Now do you know that this minus half means 1 all over? So this can also be written as half times 6x plus 4 times 1 all over, because this minus means 1 all over whatever you have positive. So this one will change to positive here. So this gives us 3s squared plus 4s minus 1, then raised to the power of 1 over 2. And then the final answer to this question, 6s plus 4 is what? 6s plus 4 divided by, then we have 2 bracket 3s squared plus 4x minus 1 raised to the power of half. And that is the solution to that question. Okay, now we can decide to continue from here. 6s plus 4 can also be written as what? 2 bracket, because what is common between 6s and 4 is 2. What will be left here? Here will be left with what? 3x plus what will be left here? 2 bracket all over 2 bracket 3x squared plus 4x minus 1 raised to the power of half. When this cancels this, you are finally left with 3s plus 2 bracket 3s squared plus 4x minus 1. And that is the solution to that question. Now this is of course to the power we have here. This is to the power of half. So let me write it where it will be visible. I can clean this and say this is equal to, your name is Yahweh. This will be y is equal to 3x plus 2 bracket 3s squared plus 4x minus 1 raised to the power of half. Yahweh, Yahweh. Now let's continue with our quest. Now you have this. Okay, this is another question entirely. Let's leave this. Now how about you are given something like this? I said try this. You have, let me give you 30 seconds to solve this and see if you get the answer. 20 seconds, 30 is too much. Your time starts now. Okay, your time is over. Now you are given y is equals to 2 sine 3 theta minus 2. I believe that you must have gotten the answer to this question. Now what will be your dy dx. Now in this case it will not be dy dx again, but rather dy d theta, because the variable here is what? Theta. This will be equals to, first of all, differentiate what is in the bracket, or first bring out the constant 2 times differentiate what is in the bracket. If you differentiate 3 theta minus 2, to give you what? 3, because 3 theta is 3, then minus 2 is what? 0. Now differentiate sine to give you cos, write what is in the bracket again, which is 3 theta minus 2. So the final answer to this question is 2 times 3, which is 6 cos 3 theta minus 2. So that is your dy d theta. Dy d theta is 6 cos 3 theta minus 2. That's the answer to that question. I believe this is the end of the class. It was a nice ride with you guys. Thank you, and please subscribe to this channel. Turn on the notification button so that you'll be notified whenever we post a new video. Also, try as much as possible to be in attendance in our classes at LT3 by 5 p.m. today. Thank you.